Hello, my name is Jose Allan Batiz Almeida, and I'm going to present to you the evidence to the proposal video. This is the circuit we have with 12 volts, two resistors of 6 ohms and one 4 ohms, and a current of 2 amperes. For the first part, we have to find the equivalent circuit of the network shown in the figure. From the terminals A and B, include the complete mathematical procedure. The procedure to solve this consists of drawing the circuit and locate where the circuit is cut. After this, we close the circuit as shown in the second drawing. Our objective is to find the northern current. That's why we are writing IN here. For this, we use the Kirchhoff law in node 1 to obtain V1. Here you can see how to clear the formula of Kirchhoff law. We see how V1 gives us an equal to 12. The following is to find the IN, that is the current. So we will divide V1 by 6, which gives us the current is worth 2 amperes. For the second part, we have to use the tools to from the Norton equivalent and write and explain what will be the fastest way to find the Thevenin's equivalent circuit and obtain the equivalent. The first thing we will do for this is to draw the Norton circuit and locate us better. Then we will look for the Norton resistance. For this, we will use the parallel resistance of 4 ohms, multiply it by the two two resistors that we have before that has a value of 6 ohms. All these give us that the resistance of Norton is equal to 3 ohms. Now that we have this from the Ohm's law, we will find the Thevenin's voltage, which will be found by multiplying the current we already got by Norton's resistance, we just found, which we can use since Norton resistance is equivalent to the Thevenin's. So we will multiply 2 amperes by 3 ohms. That gives us that the voltage in the Thevenin resistor in the Thevenin circuit is equal to 6 volts. For the third part, if between terminals A and B, a lamp is represented as a resistor RL is connected. This part of the problem divides in two. That's why we have part 3.1. If the power dissipated by the lamp is directly proportional to the heat emitted, and it's required to use this lamp for a shake incubator installed in a poultry farm, if the environmental conditions are such that the maximum heat that the lamp can generate is required, what will be the value of RL that you will use to select the device? Justify and decide from the formulas that the problem gives us. These are the formulas that the problem gives us. The solution for this. To start, we will draw our circuit including the RL, the values obtained in the previous steps. To continue, we will need to use the power law formula to find the maximum power of the circuit. This formula states that we will have to multiply the resistance L by the Thevenin voltage squared and divide all this by the sum of the resistance L and the Thevenin's resistance that is squared. When simplifying this formula, we have the, the maximum power will be the Thevenin's voltage squared divided by 4 times the Thevenin resistance. Substituting the values, we have that 6 squared 2 divided by 4 multiplied by 3 gives us the maximum power that we can have is 3 watts. For the part 3.2, we'll be using the lamp with RL equal to 2 ohms, hit more than using a lamp with RL equal to 4.5 ohms. Yes or no? Well, we will see. The solution for this, for solve this, we will use the power formula using two resistors, which are 2 and 4.5 ohms. We will find the power for the two scenarios given, which will give us that both resistors will offer us the same heat and power. that will be 2.88 watts. That make us that states that which does not make a difference between using any of the two resistors because they have the same amount of power, that is 2.88. For the last part of this problem, we have to simulate the Thevenin and equivalent circuit in FastLab and show the results of the point 2 and 3. For this, we start using FastLab the initial circuit and the Norton circuit that we used before, then the Thevenins. For to solve the part 3.1, we use FastLab, and here we can see how the values are right and give us the a very good result. Here we have the circuits of the 2 ohms and 4.5 circuits. We find that they have the same power, and this is just to justify all the work before. Thanks for watching.